welcome to 2025. I've been cleaning out the office and I realised that the last time I had this model out was nearly 14 years ago, something like that. Go back and look at my videos online and you'll see this, and I was using this model to try and demonstrate warm roof construction. So this is an update, but there's been lots of different information out there since then. I've looked at that information and I'm still convinced it's the right thing. I'm going to take you through what I still consider to be the best warm roof construction there is out there. Recently there's been an awful lot of information out there about whether or not you should be using ply or OSB on the top, and that's something that towards the end I'll be going over and I'll give you my opinion whether I think you should or you shouldn't. But realistically, if you watch this video carefully and as we go through it, you'll see for yourself that there is the reasoning between why I say what I do say, and that will be at the end. Now I'm going to put a link up here to it's like a cheat sheet for everything that I'm going to talk about here, because all the different vapor control layers that are here, and there's different ones that I'm going to list and use which are over here with all the different vapor resistance written on them, so you can work it out yourself. That will be a link which will be in the description below, and it will go directly to the website where you'll be able to either download that as a document or just read it off the website, and it'll give you all the information. And also on that page will be a link to some of the other videos that I give out to people when people contact me and ask me for information on particular things on roofs. It's not always on the internet. There's some short videos that I've done which help people. So there's about 6 or 7 little videos there. They're only 1 or 2 minute long videos, but they just help them through some of the little details. But getting back to this situation here, first of all, the new building regulations says that you should now be getting to a U value of, I can't remember what it is now, I'll put the links up here, but it's a little bit higher than what it was before. And realistically, all you've got to do is remember that it's now around about 150 millimeters of insulation. When I first did this, it was 120. So here, these are my original samples at 120. And now you should be up at 150 in the respect to height. Okay, so whether or not you should be using foil-faced insulation or whether or not you should be using tissue-faced insulation is really a big discussion that's going on, and also whether or not you should be putting ply or OSB over the top. And if you do use OSB, okay, these are the little tips that I like to try and get to people. If you do use OSB, use the T&G, the tongue and groove. The reason why is that if you've got a board over the top there and you've got another board here, and someone walks on the top and it moves up and down like that, you're going to, well, especially if you've got glass fibre, and I don't like glass fibre, but if you had glass fibre, you get movement and you can get cracking. So realistically, OSB T&G is the way to go, and we would always use that as well as the lower layer down here, OSB T&G. And the reasoning down there is because they're smaller sheets, easier to get up on a roof. They lock together, so you don't have to have the corresponding joints over the top of the different joists going backward and forward because of the way they lock together, and they're self-supporting. Some people say to me, well, can I get away, because they're worried about height, can I get away with 11 mil ply down here or whatever? A couple of facts here. First of all, you possibly could, but I wouldn't. The build up, you know, a few mil, it's just not worth saving it. And it's so much easier to work with the 18 mil OSB. So 18 mil tongue and grooved OSB down here, definitely. Now, some of the manufacturers of the insulation say that you can put the insulation directly on top of your joist there. And the problem with that is that if you're putting this down directly on top of the joist, how are you going to be fitting your air vapor control layer? Because that needs to go on top of something which is solid. Now, this stuff is designed to bridge over small gaps. It's designed to go over a metal corrugated system, because it's like an industrial system where they'd bring in these massive, great big corrugated iron sheets, they'd put it down and they'd put this over the top, and then you've got construction people with big boots on walking over it, and because you've got the ups and downs of the corrugation, when they stand in the middle of it, they don't want this to break. So this will take someone's weight over I think it's 150 millimeter gap, and will not break and sag if you're using the correct air vapor barrier. Now, you see a lot of people use this. Now, this here is an example for a cold roof. This is not to be used on the top. This is to be used down here above the plasterboard here, but you can't put your lights through it. You can't cut your lights through it. Now, the reason I got this here is because in my cheat sheet, which is on the website, which is the link will be down below, as I said before, I go through all the different examples of what an SD value is and a meganewton per second, meganewton seconds per gram. And the reason I don't use that, which I always reference the two of them, but from now on I'm always going to reference the SD value because it's so much easier to say, because that's just a mouthful. So the SD values on everything I've put together. Now, this gives you an idea. Now, this is a really heavy gauge air vapor control layer. Green is the colour for the plastics of which will be used. If it's not green, it's probably not an air vapor control layer for a cold roof, which would go down there. Now, the reason I've got this out is just to give you an example of why we are using, and have done in the past, use this Alytrex 600, because it's so good. Now, the Alytrex 600, and again, this is a 12-year-old sample. This has been in here for 12 years with all this kit when I first did this, and yet still, as we pull it off and get underneath there, it's still tacky. And if I leave any of it on top of here overnight and I come back, I just can't get it off. So just have a look at the SD value of this. It's 1,500. So the point I'm trying to make here is that at 130 with an air vapor control layer down there, that is not a brilliant air vapor control layer. My point here is that this is amazing at 1,500. Now, I've been talking about the Alytrex 600 for a long time. Recently, I've been using this particular one, and I'll put a link to it again in the sheet down below. This is 1,300, but it's a lot. It's an SD of 1,300. When you're up to 1,300, where this one was 1,500, the 200 doesn't make any difference. They're all about the same. Just as a matter of interest, this is one that I tried. This one was great because it came in 2 meter lengths, 2 meters high by 30 meters long. But I found it very difficult to lay, so I don't use this particular one. But again, this one's up to 1,500. So sticky back, like all of these are. And the reason you want to be using these is because they are sticky back. They seal themselves down. Now, this is where I want to get to the point here, is that this air vapor control layer, whatever one you're using out of these, they are unbelievably high at 1,300 against 130, unbelievably high. Hence where we're going to get to, and my reasoning behind whether we should or shouldn't use ply on the top. But where we're going with all of this is all based on you work it out yourself as we move along. Very, very high air vapor control system here. Now, gluing or screwing down, as you know, thermally broken fixings I like to use as often as I can, and as they penetrate through, I do a video, as they penetrate through this, it self-seals pretty much as you go through here. Did a video later on, I'll link to it again, where I go through it and I put water around it and no water runs through it. So if you get this right, now I only put this here last night and you can see what's going on. So, you know, the way it sticks. Now, you just take a look at this. What we got here is a build-up, depending on what you're doing here. What I'm trying to show you is hopefully pretty obvious with joists. This is a warm roof construction. Your ceiling down below, your light coming up in there. Again, I talk about this all the time. This space in here is the same temperature and relative humidity as the room down below. People say to me all the time, oh, you shouldn't have wood up here. The wood here is the same as your table downstairs. If your table downstairs doesn't rot, why would you think any of the wood here would rot? All of this is below the air vapor control layer, and therefore it's classed as internal. By putting the air vapor control layer up here, all of this wood and all of these is classed as internal. Now, we've got a very good air vapor control layer there. We're going to build our warm roof construction up here. Now, got a few different choices. We can pretend this is 150 mil high. It's not, it's 120, but we could use this particular one. Now, again, in my cheat sheet, which is linked below, is the vapor resistance of this, and it is low. Now, I'm not going to quote it right now because I can't remember, but we are around about an SD value of about 30. That's all we are. When we go to something like this, we're an SD value of around about, I think it's 50 to 70. My point here is that compared with a product like this, which is 1,500 or 1,300, the vapor permeability of that and that is poor. Now keep that in mind. It's poor. It's poor. Of course, the vapor permeability of this is a lot better than that, and it's the foil that is doing most of the work with something like this. So there's your insulation. And what we would normally do, and I've made a fall on this roof. If I was to pour water on this roof, it'll all run off this way. So as you're building this roof, and again, these little videos that I will link to, in which will be a link down below, show you videos of us doing this. One of the reasons we use it like this, and look how this has been patched up. It doesn't matter because it all sticks together so well, and you're not using other products to stick it together. It just sticks to itself. The water runs off. If we were on a job doing this, we would get this roof watertight. People can work in the rooms down below. But the problem is that if you had an edge around it, like this, all the way round, which you eventually want to do, along there and along there, if you had that all the way round, you formed a swimming pool. And unless you can do the whole job in one day, you can't do that. So what we would normally do is that we'd put this side on, this side, and we would leave this side and let the water just run off. And you could leave this outside now for a week, a month, whatever you want to, until you get a good weather window. Then you can start doing your build up. And then the minute you do, you've made sure your insulation, and these are the vital things that you must do. You must make sure that your insulation is kept dry, kept inside. Get it delivered the day you want it or the day before that you're going to use it, and make sure you know where you're getting it from. I do another video, which I'll put a link down below, showing you that I've been into many yards and it's sitting outside and it's soaking wet, and when you get it, you can see that it's wet. So you've got to make sure that now this sandwich that you're going to make is dry. You come along, you start putting your edges on. You put this edge along here. It doesn't matter that you're going to join it. You're going to join that to that. You're going to come along this side. You're going to join it. You've got all the sides all the way around. Now, once you've got all the sides all the way around, you're going to put your insulation in there. If you're putting your insulation in there and your insulation is that high, which is slightly higher than that, there's no reason why you can't. Now, I've left that flap up to show you that I would bring the air vapor control layer over the edge. Now, this is really important. I've read lots of documents on this. If you note here, this is a wall around the back here. The air vapor control layer is stuck to the wall. There's no movement of air up the back of this because of the way it's stuck to the wall. One of the things that people say to me all the time is, but the wall, you can't get it to stick. Yes, you can. Paint the wall with Unibond. We use spray glues, which we have in big containers, and we will spray this with a contact adhesive. We'll go around the wall, we'll make sure it sticks. You must be airtight. What you don't want is you do not want air which is laden with, or could be up to 55–60% relative humidity. You don't want that coming up the back here and getting into your roof construction. And this is the whole point. This is airtight. This is airtight. This is airtight. You're airtight there. You're airtight there. You've got none of this warm, moist air going through there, getting up the back and coming up the back there. Now, it's really interesting because if you read the building control documents, they talk about lapping this back over the top. They don't talk about sealing it to the top here or sealing it at the back there. They just talk about bringing it over onto the insulation. And I'm going to show you why I don't think that is relevant. It's more relevant here and it's more relevant there and there. Okay, so let's just follow on that. We've got all our vapor higher than the insulation there. If we're going to put a decking on, okay, because we might not. If you don't want to, you can go straight over the top of this with your chosen product. If you're using felt, you'd use a different type, but this one's designed to go over with a single ply membrane if you want to. But the problem is that it's soft, and the problem with it being soft is that it will dent. You can't put ladders and things like that on it, etc. And we get a lot of customers who just don't want that. They want, and also we're doing lots of balconies and things like that. So you have to put a hard surface on the top. Now, there's your hard surface on the top. That could come over the top there. You've got a gap. So what do you do with that gap? There's loads of different ways that you could finish it. Preferably, I would bring it up like that, and I would go straight over the top like that, and then you've got a really good finish. And of course, you can just build it up as much as you want to. If that was 150 mil, you could build it up all the way. That's going to bat up against the back there, and then you're going to put your membrane down. Now, when you put your membrane down over the top, now of course, just so you know, to make it as clear as I can, I haven't, because I'm filming, put the front on, but this would run all the way down here and all the way along there, and it would be completely around. So if I had the front on there and I lifted this out, if that was finished correctly and the front was finished across there correctly, I could fill this up with water and it wouldn't leak. That's where you've got to get to in air tightness. I mean, obviously it's going to be watertight if I fill it up with water, but because of that, you've got you've got nothing coming up, and you know you've got an air vapor control layer, which is unbelievably good. So stick all this in and get it all ready. That's all over there. You've got that all finished off nicely all the way round. Now, for wind uplift, because you've got this going all the way around the perimeter, screwing straight through into this around the outside, which when you think about it will normally be not over the livable area, so you haven't got any thermal problems around the perimeter, because normally on the outside of all this your walls are around about 250 to 300 millimeters thick, so you're way outside of having a thermal problem. And where do you want all the fixings? The more fixings you've got around the outside, the better you are, because of what we call wind uplift, and that is wind hitting the front here, coming up, a vortex, and then sucking the roof off. Your membrane then goes over the top of your wood. If I push that to the back there. Now, this is the point I wanted to make. Once that membrane goes on and it goes up and it's sealed to the back there and all the way around, you've got a sealed sandwich. You've got everything inside that sandwich. Nothing is going to get in unless it goes through the materials to get in. And that's my whole point. Now, if I show you this, so my blue Peter thing, this is one I did earlier. So let's just have a look at what I've got here. Now, the reason I'm taking that off is because this stuff sticks to everything. So this is the same model here, but without the wood around the outside. I'm looking at the back. My insulation is locked inside. Look at this. All the way around, if that was over the top of that timber there, that's how you're finished. This is going up the back of the wall. We've got air vapor control layer everywhere, sealed around it. That piece of insulation in there is 100% sealed in there. There's nothing going to get in there except for any vapor that will go through the air vapor control layer, because it is an air vapor control layer, not an air vapor stop. So the moisture here little particles could get in through this, but it's going to be minimal. But here's the thing, the SD value is 1,500 of this. SD value of your roof membrane is probably going to be 100, 200 or 300. So whatever you get through there is easily going to get out of there. It's not going to build up. Of course, if you had everything the wrong way round, where you had something up here which was a high SD value and a low SD value here, you're going to get a build-up inside it. And that's exactly what you do not want. Theoretically, if you start looking at what's going on here, any moisture that was in there, be it minor, because remember, you want to keep that in there absolutely as dry as you can, any moisture that is in there could slowly get out anyhow, as long as not so much as getting in. But we're talking about minute movements. You do not want moisture in there in the first place, but slowly it will come out, because this is less than that. So over 2, 3, 4, 5, 6 years, any moisture in there should get out. But the catch with all of this is you've got to make sure that you've got a robust construction in the first place. If you don't put this in and get this really, really tight and airtight, then it's vapor permeability. It's 1,500. It's SD of 1,500. Doesn't work. If you've got a hole in it, it doesn't work. I've got loads of examples of roofs where, first of all, they've used the wrong thing. They may have used something like this, and this is a 1200 gauge proper air vapor control layer. But how do you join that? And so therefore they've butt it up there. They don't join it together with tapes. They don't do anything with it. They cut holes through it. It's leaking like a sieve. If the air vapor control layer is leaking like a sieve, it's got no use whatsoever, in which case you've got moisture that is coming up through. And if you've got moisture that's coming up through and there's more of it than what your top membrane will let out, you're going to get a build-up inside. And that leads me to start talking about build-ups of insulation. So over here, we've got, because I get asked this all the time, would you use 2 or 3 different layers of insulation in a build-up? Now, if you look at this, it's a very confusing construction for the vapor. First of all, look at the amount of possible vapor barriers that we got. 1, 2, 3, 4, 5, 6, 7. And you always have a vapor barrier at the very bottom. Now, the reason that this will work is because the vapor barrier at the bottom is the strongest thing that you've got going for you. And that's why it works. It's a confused construction. It's not the best way of doing it because of it being confused, but we've seen it work many, many times, and it doesn't cause a problem as long as you make sure that you've got an air vapor control layer at the bottom. Now, interestingly enough, it's actually got quite a lot of virtues to it, because do you imagine that this was 2 pieces here, say joined together, one there and one there, that gap gets covered by the one above. So staggering all of these, putting them all together in layers, can give you a very, very good thermal performance, rather than just having 2 or 3 sheets pushed together where you've got a possible thermal gap somewhere where you can have thermal bridging. So I'm not against putting foil inside, although I would prefer to see a tissue face used, if possible, in many layers. And when we do tapered insulation, we end up with 3 or 4 different layers. And of course, tapered insulation, if you didn't know, I shouldn't say of course, because you may not know, will only come with a tissue face on the top. But here's the thing. Let's go and live in the real world. Living in the real world, I can tell you this. All your suppliers are stocking this kind of insulation. Nobody, unless you order it, is stocking tissue faced. So so many roofs out there are being done with this and not this. And we will do our roofs using foil faced as well, because we can't get hold of this a lot of the time. It's not only more expensive, it's a lot harder to get hold of. So although that is the preferred method because of what I've just explained to you, without the confused build up, using a foil is the way to go. So the next problem is fixing it down. As I've said to you, I prefer using thermally broken fixings. A lot of people are gluing this down. Now I've got to show you, I've got a piece around here somewhere. There are different types, and this Rectosil is one of the better types of insulation. I don't know what make this particular one is, but look how easily that peels off of there. Where this is so much more robust, and getting the foam to stick to it is something that, as you can see, it works. Now the problem is that trying to get manufacturers to give you a specification and say their product will work with someone else's product and vice versa is a nightmare. Unless you go to some of the really big boys out there who charge a premium to do a whole, what they call a system, and they guarantee the system, you don't get it. So it's a matter of making sure that you get all the products together, you make sure they work, and hence that's why I like a robust construction, and you build in all these different scenarios to make sure that it's going to work. We've built in that we've got the best air vapor control layer underneath it. We build in onto the surface here that we seal it all the way around. I'm going to go back to this, and you know, we make sure that when we go around it's nicely sealed in all the way around here so that it's absolutely airtight. So you know, the takeaways from this are: make sure that you have got a really good air vapor control layer at the base just here. And in the link below, I'm going to link you to another video, because a lot of people again ask me about how you bring tiles down and you finish this off on this on the edge here, and you separate a cold roof from a warm roof. And that I've got a few videos which I'll link to. But more to the point, you might have seen me with the board on the background just here, is that I do a video talking about the sarking felts, because the incorrect sarking felts are being used, and that video again will be linked down below, and I think I'll put a link up here to it, because that's another thing that is going really wrong in the industry, the wrong use of the sarking felts. So let's get on to talking about whether I would put ply or OSB, and I would always use OSB without a doubt, over the top of my insulation. And the answer is yes. And why? Okay, well, you look at the figures, and again in the link down below I will link to plasterboard. If you think about this from top to bottom, your plasterboard will give you a vapor resistance. So in the sheet which is listed on the website, it will tell you the vapor resistance of your plasterboard. It will tell you the vapor resistance of this ply and the OSB if you're going to use it. It will tell you the vapor resistance of several different types of damp proof, 7 different types of air vapor control layers. It will tell you the different insulations and what their SD values are. Again, what the SD value of this is, what the SD value of glass fibre, some vinyls, and some EPDM. And the takeaway from all of that is that by such a long distance, your 1300 to 1500 air vapor control layer down here is so good that the build up of this doesn't come anywhere near it. In which case, Any moisture that is in here is going to get out with less getting in which case, unless you have a leak on the roof, and that's the key thing with all of this, don't have a leak on a roof like this. Maintain it. Make sure all your flashings are done so well, and make sure that you maintain this roof. You're not going to have a problem. I reckon that we've probably done 5, 7, 800,000, 2,000 smaller roofs, massive, great big, I mean, thousands of square meters of EPDM, working with different roofing contractors that I use, felt roofs, all sorts, all with ply underneath them or OSB underneath them, and we've never had a problem with them. However, the ones that we do go to that we have problems, when we start opening up the roofs, we normally find the problem is around the edge, and that's because they haven't finished this off properly and you've got moisture coming up into it, or as we get into it, they haven't used the air vapor control layer, or they've used the wrong one, they haven't put it in properly, and it's just general detailing around the outside. So on that basis, I think I've covered everything. If you need more information from me, always just get in touch. I love seeing your videos. I love your questions. The more information you send me, the more I can help people. The link to a lot of this stuff is going to be down below. And I've got a few other videos coming out as well to do with some of these new plastic fittings for dry fix ridges and hips. Again, big problems with those. Need any more help? Please get in touch. Speak soon.